Today we're going to talk about something called logarithms. Now, logarithm is something that you've not heard before, but it's incredibly useful when we're trying to work and solve exponential equations. So we're going to be using this term a lot, and we're going to be going back and forth between logarithms or logs and exponential functions or exponents. So the definition of a logarithm with base b, let b and y be positive numbers where b is not equal to 1. The logarithm of y with base b is denoted by log b of y and is defined as follows. So we'd say log base b of y, that's how you say it, log base b of y equals x. That means that b to the x power equals y. So I want to talk about this for a little bit so that you can really understand what's going on here. So we have log base b, and then you have b as your base number being raised to a power. And notice that the log part and your exponent x are on opposite sides of the equation. So that's why right here we say logs equal exponents. And then finally, the y part just kind of hangs out there. So the way I like to do it when I convert from exponents to log is I say, okay, what's my base? And then the exponent goes by itself on the equal side. So let's write that over here. So if I have b to the x equals y, and I want to make this a log, I say, okay, we're going to write the word log. Then what's our base? What is being raised to the power? Okay, b is. All right, so b. Log equals exponents. So my exponent's going to go on the other side. And then the y just hangs out with the log. And you'll see that's what we have over here. And I'm going to be doing this for all of these problems below. So rewrite the logarithmic form into exponential form. So what's our base? Our base is 2. The log equals exponent, so 5 is my exponent. And that will equal what I call the other number, 32. And now if we look at this exponential form, it should make sense. 2 to the 5th power, if we type that in our calculator, that equals 32. The next one, log base 7 of 1. Our base is 7, and that is being raised to the 0 power because log equals exponents. Let me use the same colors for all the problems. 7 being raised to the 0 power, and we know that anything to the 0 power equals 1. Well, that's our other number, 1. So you can kind of see how this might be useful for solving exponential equations. Okay, our base number here is 13. Logs equal exponents, so our exponent is 1 equals, and if we know 13 to the 1st power is 13, which is also the other number right here. Right, our base of the next one is 1/2, so we have 1/2. Our exponent, log equals our exponent, so it's -1, equals the other number, which is 2. Again, the word log and our exponent are on opposite sides of the equation. So the word log is on the left side. Our base is 18. The number on the opposite side of the word log is our exponent, so 0. Equals 1. And again, that makes sense because anything to the 0 power is 1. All right, down here, we're going to evaluate these logarithms without a calculator at first, and then I'll show you how we can use a calculator to evaluate them. So the first thing I like to do is make these all equal to x, just so we can kind of see where things go. So now our base is 3. Our exponent is x, and that will equal this other number here, 81. So we ask ourselves, 3 to what power equals 81? Well, that's 4. So x would equal 4. Okay, now this one, set that equal to x. 4 to the x power equals 0.25. Well, what number, or 4 raised to what power would give you 0.25? Well, you probably know that 0.25 is 1/4. So x would have to equal -1, because remember, 4 to the -1 power is really 1/4. And then letter C, we have 1/4 is our base to the x power equals 256. So again, we know that 256 to the 4th power is 4. And if you wanted to, you could rewrite it like this. 1/4 to the x power equals 4 to the 4th. And say, well, how do we get there? Well, x would have to be -4. So that way we would have to flip the fraction. So I understand that some of these would be hard to just figure out on your own or to remember. So let me show you how to do it on the calculator. So on our calculator, if we press alpha and the window button, you see that 5th one down here, it says log base. Hit enter, and we can see, well, we can type in 49 as our base and 7 as our other number, and we get 0.5. 0.5. And if we were to do this the other way, it would still make sense. This is an easier way to do it. We can try one of these up here that we did. So alpha window, 4, and then 0.25. I hope we get -1, and we do. So now let's do the other problem down here. 1/3 and 9, and we get -2. And here, again, if you wanted to write it like this and say, 16 to what power equals 4, you may say, well, the square root of 16 is 4, and we know the square root is also the 1/2 power, so we can kind of get an idea that we should probably get 1/2. We get 0.5, which is 1/2. So 0.5. So the calculator does make it a lot quicker to get these answers. Now let's go to the next page where we have some common logarithms. If your calculator, some of the scientific calculators don't have a base option, or you might have said, well, isn't there this log button right here next to the 7? Can't you do that? Well, if you do that, you see there's no base. That's log base 10. And before, I would say maybe 10 years ago, you could not do this up here on these types of calculators. You'd have to use log base 10 and do some other work with that. So if you ever have log base 10, you can just press the log button and type in the value and get your answer. Now log base e, if we had a log base e, that would be the ln, sometimes called, or always called, the natural log. So log base 10 just looks like log in our calculator, and log base e is abbreviated ln in our calculators. So let's type these into our calculator without using the alpha menu. Because it's log base 10, we can just type in log 1.234 and we get 0.09. And then over here, let's do the natural log. So ln of 31.2, oops, and we get 3.44. Again, it says to do these down here without a calculator, but I want you to pause the video and use the calculator to get these answers. Remember, alpha and window to get that. So pause the video, and once you're done with these, let me know. Unpause it, check your answers, see if we get the same thing. All right, so this is what you should have gotten. I let them in decimals or fractions. If you were doing this without a calculator, then you would have gotten the fractions probably. If you did it with the calculator, then you would have gotten the decimal approximation. The last problem down here, it says the sales of a certain video game can be modeled by that equation, where Y is a monthly number in thousands of games sold during the X month after the game is released for sale, and X is greater than 1. Estimate the number of video games sold during the 10th month of the game after the game's release. So this means that X is 10. So we're going to plug that in. 200 ln times 10 minus 1 plus 35. So we have the ln, whoops, let's clear all this stuff. ln of 20 is first, 20 times the ln of 10 minus 1, close the parentheses, plus 35, and we get 78.94. 78.94 thousands. That's our units right there of games. Right, so I know this log thing is very intimidating at first, but the more that you use it, you'll realize that it's really not that bad. It's just switching from log to an exponent form or exponent form to a log form. And as long as you go about it the way that I was talking, where identify your base and identify your exponent, it does become a lot easier. So thanks for watching. Make sure to like this video and subscribe.